Alright, in this video, I'm going to take you through an example of how to graph a polynomial that you can't, has a higher degree than a quadratic and also can't be factored by traditional methods. So can't be factored by like grouping, meaning you must use like synthetic or long division to factor it. Alright, so the order of these don't really matter, but the first thing I'm going to do when I see a graph is determine the end behavior to get that out of the way. So for this graph, the end behavior is going to be as x approaches infinity, f of x does something, and as x approaches negative infinity, f of x also does something. Now, I wrote it like this to show you that the purple part is going to be the same every time you write the end behavior. You say, what happens to f of x as x goes to the right, and what happens to f of x, y, as x goes to the left. Alright? So the part that changes is going to be in red, and by changes I mean depends on the problem. So for this problem, to determine what happens as x approaches infinity, so as x moves to the right, you look at the leading coefficient. And since it's positive, alright, there's really like a 1 in front of that x cubed, f of x is going to approach infinity to the right. So if I were to keep like our graph down here and just add to it as we learn stuff about it, alright, I know that at some point it's going to go that way to the right. And as x approaches negative infinity, so as it gets extremely to the left, f of x is going to approach negative infinity, and that's because, well, it's an odd function, and odd degree. So it's not an odd function. You could try to prove that, but you would fail. It's not an odd or even function, but it is odd degree because the highest exponent of a variable is 3, which is odd. So it's going to go in the opposite direction to the right. Okay, and I'm actually going to move this over a little bit to around there. Okay. Now let's list all the possible zeros. So we don't know our zeros. We can narrow them down to all the factors of 24 divided by all the factors of 1. Alright, so for B, that's going to be 1, 2, 3, 4, 5 is not divisible or doesn't go into 24, but 6 does, 7 doesn't, 8 does, 9 does not, neither is 10 or 11, but 12 does, alright, and also 24, okay? And then, oops, that's ugly. And then, alright, all those numbers divided by 1, so it doesn't really change anything. If it was a 2, then, it would be all those numbers plus half of all those numbers. So you have some fractions. Alright, positive or negative, okay? So those are all the possible rational zeros, and that's the kind of the pool of numbers I'm going to use for step C. Alright, so use synthetic division to find at least one zero. Alright, so we'll do that over on the right here. So I'm going to, this part in black is going to stay the same every time. So that's our little L for division, and we got 1x cubed minus 5x squared minus 2, and then 24. Okay, so first thing I'm going to do is try 1. Alright, so now we're just pretty much guessing and checking these zeros here to see which one is a 0. So let me try 1. Alright, bring down the 1. 1 times 1 is 1. Add that to negative 5, we get negative 4. Multiply negative 4, add, we get negative 6. Multiply, we get negative 6. Add, we get 18. Alright, so since this number is not 0, we know that 1 is not a 0. Alright, so we have to try again. So the next number I would try is negative 1. And there's really no, you could try numbers randomly, but I always like to work with integers closest to 0. So I go 1, negative 1, 2, negative 2, 3, negative 3. Alright, and that's your best bet to find the zeros as quickly as possible. And I could explain that more in another time, but it really doesn't matter. But use the easy numbers first. So we're going to go with negative 1. So we got multiply, we got negative, we got negative 1. Add, we got negative 6. Multiply 6. Add 4. Multiply negative 4. Add 20. Alright, the remainder isn't 0. So negative 1 doesn't work. Alright, so now we're going to try 2. Okay, so if you're doing this on like a test and you can't use a calculator, alright, now we have to go to 2. Alright, but if you're doing this at home, I encourage you to cheat a little bit. And by cheat, I mean to just graph this on a calculator if you're having trouble finding the zeros, meaning like you tried a couple rational zeros and none of them worked. You're getting frustrated because you did synthetic division like 5 times. Don't worry, just cheat. And by cheat, I mean try to graph it and see if you can find one of the rational zeros from the graph and then just immediately go to that one. All right, so let me show you what I mean.